Hi, welcome to this lesson on trigonometry, trigonometric functions part 2. Let's have a look at question 5. We're given the function f of x equals 3 times sine of x minus 60 degrees on the interval negative 90 degrees to 270 degrees. They will ask us to sketch the graph of f and clearly label all intercepts, turning points, and endpoints. Okay, so we have a general function of the form a sine bx plus p plus q. And the only parameters affecting the parent graph sine x is this a equals 3 and this p value of negative 60 degrees. So what's actually happening? Well, according to BODMAS, we look at brackets first, that negative 60 degrees is telling us that there's a phase shift of the parent graph sine x by 60 degrees to the right. And then the 3 in front of that sine means that we are stretching that graph now by a factor of 3 units. Okay, so let's go ahead and plot some points on here. They've broken it up into 30-degree intervals. So let's type our function out. Okay. So we want to start at negative 90 and we want to end at 270 and we want to step in 30-degree intervals. Okay, so at negative 90 degrees, it's negative 1.5. Okay, so here's negative 1. So negative 1.5 will be up here. All right, so that's an endpoint, so let's label it negative 90 degrees, negative 1.5. At 60 degrees, negative 60 degrees, it's negative 2.598. So here's negative 3, so negative 2.598 will be somewhere over here. So at negative 60 degrees, it is that point. At negative 30 degrees, it's negative 3. Negative 30 degrees, negative 3, and that'll be a minimum turning point. Okay. So how do we know that? Well, the standard range on a sine x graph is negative 1 to 1. Because of that a value, everything gets multiplied by a factor of 3 for the y values. So it becomes negative 3 to 3 for the new range. Then for 0 degrees, we go back to this intercept here. So 0 degrees and negative 2.598 is the y-intercept. Okay, 30 degrees is negative 1.5 and 60 degrees is 0. So that's over there. So that's the x-intercept. Okay, and then 120 degrees goes to 2.598, then 3, then back down. Okay, so here's 3, so 2.598 will be over here. So 90 degrees, it's over there. 120 degrees, it's 3, which will be a maximum turning point. And then back down for 150 degrees to 2.598. I've got those shifted over. Okay, so 90 degrees is 1.5. All right, okay, let's see if we can just bring all that back up very quickly. There we go. All right, so let's correct those points over there. Okay, so 90 degrees was 1.5, which is over here. Okay, then 120 degrees was 2.598, 150 degrees is the turning point. At 180 degrees by symmetry will be back to that, 2.598. Then symmetry will tell us 210 degrees, that will be 1.5. 240 degrees will be 0, and negative 270 degrees will be negative 1.5. Okay, so that's an endpoint, that's an x-intercept, so we label them. Okay, so we connect this graph, play our game of connect the dots, and we get a nice graph here. All right, so that's the graph of f. We've labeled x and y intercepts. There's two x-intercepts over here, one y-intercept, 2 turning points, and 2 endpoints here. All right. For which values is f of x equals to negative 2? So if we go to our diagram here, let's get a sense of how many solutions we will expect. So negative 2 is over here. So if I just draw the y equals negative 2 line, on this graph, we expect 2 solutions. One that looks like it's going to be a positive number between 0 and 30 degrees, and the other one a negative number between negative 60 and negative 90 degrees. Okay, so let's go ahead and work those out. So f of x is 3 sine x minus 60 degrees. That's equal to negative 2. So we divide both sides by 3. So we get negative 2 over 3. So here's the trigonometric equation. Get your cast diagram. Where's sine negative? Third and fourth quadrants. So the reference angle is going to be sine inverse of positive 2 over 3. So shift sine inverse of, 2 over 3, okay, 2 divided by 3, 41.81 degrees. Okay, so the quadrant 3 solution will be x equals 180, or not x, okay, be very, very careful. What is the angle inside? X minus 60 degrees, good. So that will equal 180 plus this reference angle, so 221.81 degrees, plus k times 360 degrees, and the quadrant 4 solution will be x minus 60 degrees, the angle, equals 360 minus that reference angle. Okay, so let's put 360 minus the reference, and we get 318.19. Alright, so now we solve for x, so we add 60 on both sides, so that's going to give you 281.81 degrees plus k times 360, and this one's going to give you 378.19 degrees. Okay, so now we need to put our k values and see which ones give us solutions in that given domain. So for the first one, if I put k equals 0, I'm going to get 281.81 degrees. That is outside the domain, so it's not applicable. If I put k greater than or equals to 1, all integers 1, 2, 3 onwards, I'm going to get values that are much bigger than 270, so that's not going to work. But what about k equals negative 1? So now I'm going to do 281.81 and minus 1 amount of 360, and I get negative 78.19. Okay, that is within the given interval, so that works. And then anything less than or equals to negative 2 is going to be not applicable, because it'll be much more negative than negative 19. Same thing over here. If I put k equals 0, then I get a not applicable solution, because I get 378. Anything bigger than or equals to 1 is also not applicable for k. But if I choose negative 1 now, let's see, 378.19 minus 1 amounts to 360, and I get 18.19 degrees. And that is within the domain. And then anything less than or equals to negative 2 is going to go outside that given domain. Okay, so 18.19 degrees. That makes sense. Okay. And then negative 78.19 degrees. That also makes sense based off that diagram. Okay, so those are the two x values that will give you negative 2 when you substitute it into the function. And then lastly, for what values of k will f of x plus k equals 0 have no real solutions? So f of x plus k equals 0 can be written as 3 sine of x minus 60 degrees plus k equals 0. So I've just replaced f of x. Then I'm going to subtract k on both sides, so I get negative k, and then divide both sides by 3. So I get negative k over 3. Now, sine of x minus 60 degrees, right? This is just sine of an angle. So in the normal sine x graph, the range is between minus 1 and positive 1. So therefore, that means that this graph here must also be between 1 and minus 1. That is when sine has its range values. But sine of x minus 60 degrees is negative k over 3. So I can solve this. If I multiply both sides by negative 3 now, so be careful, I'm multiplying by negative 3 to get rid of this negative 1/3 here, then the signs will change. So this will become positive 3, k, and then greater than or equals to negative 3. So how do you read this? Okay, so if you looked at it in a mirror, the way you would read it is k is less than or equals, right, to positive 3, and greater than or equals to negative 3. So on a number line, it looks something like this. Okay, so what is this telling us? This is telling us when the range is satisfied. So these k values will have solutions. So therefore, outside of these k values, there should be no solutions. So therefore, no solutions if and only if k is greater than 3 or k is less than negative 3, where k is a real number. Okay, so that's the algebraic proof. But if you just look at the graph, okay, can you see that this graph here, right, the minimum value is negative 3 and the maximum value is positive 3. So if I draw straight lines y equals k here, can you see if it's above 3, it'll not cut the graph. And if it's below -3, it will not cut the graph. So that's exactly what this algebraic statement is saying. All right, so that's how we would do this type of question. I'll see you in the next one.